My name is Alexander Rieber, and today I want to talk about learning to learn with AI. We know that AI boosts productivity. Um, First, for everybody, I have prepared a slide deck for like 20 minutes, so I will skip many slides and keep you in touch with the main point I have to make. And what we know from the literature is that LLMs can boost productivity. But in education, not the productivity, but also the process, how to acquire knowledge, new things, learning new things is the relevant part. And there's not so much about it in the literature. The most recent setting is from Strömberg, Lei and Wu, which had a look at Chinese secondary students. What we are doing now is we are looking at university students in a bachelor's course from the third and fourth semester. And what we have is information about their really task level commits. We can look at Git commit data from small study groups, and we can link this Git commit data to their final grades, what they did in this final exam. What we have is this mandatory third and fourth semester management and economics course, which is done via Git and GitHub, and it's done with real data. So if anybody's interested, we have these projects posted online. They scrape data from the internet, or they acquire it via APIs or data stream, for example, and they answer real economic questions with the use of mathematics and computer science. And we have the data from these students from the beginning of winter semester 2021 up until recently. So we know what they committed before and after the introduction of ChatGPT. We have a link between individual tasks in these projects. The project has like 15 different tasks to do, and we know which person, which student committed which to which task, and we can link this to the grade they get in this for this specific task in this specific project, and also to the exam later on. What we also have is their Abiturnote. The Abiturnote is the high school GPA. So we have their like baseline ability, so to speak, and we can see if LLMs did different things to different students. I call them weaker or stronger students at the end. Our identification strategy is such that we look at strong and weak students and how they perform before LLM was introduced and after LLMs were introduced. And what we can see over the course of over the semesters we did this course is that we have like pentagram detecting AI contributions from all these different projects, from all these different groups that did these projects. And we see that the LLM generated text we have in these contributions, in these projects, is steadily increasing. For GPT 3.5 until GPT 4, it was roughly below 12%. But then it was steadily increasing, and from winter semester 24-25 onwards, we had access to something called BV GPT. That was a free access for all students in this course to GPT-4. And then we see, okay, it really skyrockets with about 60% in the summer semester 2025. What we see is that weak and strong students use LLMs to generate their text. However, weak students use it slightly more often. But what we also see is that the distribution within these project courses, within these project groups, got compressed. So now, after LLMs were introduced, weak students commit more often, or all students commit more often to their projects. Before, mainly strong students committed to these projects, and there was like this kind of free rider principle of weak students. But after LLMs were introduced, everybody committed to these projects. This is also what we see in here. We have differentiated every task if the students committed code or committed text to a specific task. And what we see is that the strong students had the majority in contributing code and also contributing text to these tasks in these projects. And the weak students, they've been like 20% or 30% committing code and also text to these tasks. But after LLMs were introduced, we see that both groups roughly do the same commitment. Remember, we have like 3 students in each group, so 33% would be everybody committed roughly the same amount of code. Or here the text is a little more on the side of the strong students. What we can observe is that the code quality got way better after LLMs were introduced. This graphics shows the lint warnings per line for the contributor that did these coding tasks. And if you don't know what linting is, they have a style guideline, and you should follow this style guideline in your coding. And normally, students that are not very good in coding in this course, they learn how to code, but probably that they're not that good a coder when they start to implement it. Then you would assume that the linting is between like 1 and 2. So there are many problems in the code, and an automatic linter would do it differently. And what you see is after ChatGPT is introduced, the lint warnings go down quite heavily for weak and strong students. So this suggests that they really use LLMs to generate their code. And it's also the same when you look at what they get as a grade for these specific tasks in this project, you see that before LLMs, when good students contributed code or also contributed text, these answers were better, almost always better than the answers provided by the weak students. But recently, when both groups use more LLMs, the answer quality in the project itself isn't that much. Yeah, you cannot distinguish these answers from good students versus bad students, strong versus weak students. But what we see when we link these project answers to the questions in the exam, in the final exam, is that when strong or weak students committed code before ChatGPT was introduced, they performed way better. It's 20 percentage points better in here when they contributed code to their to this task. But basically, after ChatGPT was introduced for weak and strong students, there's not much evidence that contributing code is also a process in learning, because we see this pattern here that code is not predictive of the final exam grade anymore. For text, we didn't have any predictive power in the whole sample. And this is also what we see when you look into regression. Strong students go down like 7 percentage points, but in the final exam after ChatGPT was introduced, but weak students did not move much in the final exam. What we see here, it's not significant at all. So the distribution, the compression we saw before is all about strong students lose instead of weak students gain. We have some robustness tests, but I will come up to the implications. The equalizing the output with LLMs is not equal to equalizing learning. It's the signal collapses and strong students pay the price. Thanks.
Excellent. Thank you, Alex. With this, I'll open the floor for questions from the audience. So there's one question in the chat. Does this mean that weak students benefit more from GPT? How might strong students benefit from GPT equally?
It's the case that strong student and weak students use LLMs, and before ChatGPT, strong students struggle when using like coding. They didn't code before. They learned coding in this course. It was like they look at Stack Overflow, and Stack Overflow doesn't provide you with an answer. You have to adapt this code to your question. And now they just copy and paste from the LLM the answer, the code they get from there. They don't think about what they're doing. That would be my take from it, because the strong students they use LLMs, but they get like more productive, okay, or with they stay the same. The productivity stays the same, but they do not invest so much more so much time in it to answer. Say a bit more about the class. The class, it's in German. It's project course in data science, so they learn how to program in R. We have a theory phase at the beginning where we introduce R. We introduce the concept of statistics and how to do statistics in econ. We teach them how to do instrumental variables. Diff and diff, what are fixed effects, what is clustering, and this kind of stuff in the third and fourth semester. We have it's mathematics and economics and management students sitting in there. What they are doing in the exams. In the exam is not code heavy. The exam is interpretation of the slides of the graphics and the tables they produce. What is the project? I can give you. I will put in these projects in the chat. Then you can have a look. Given that we're talking about the signal.
Yeah, go on, Alex. Given that we're talking about the signaling model.
Yeah, how confident are we that this approach provides useful human capital for future careers? There was one thing what we deliberately said, okay, these projects are done at home, so students can access every LLM they want, and there's no way, or we do not do them in class and give them like say, okay, now do them in class. So we deliberately say you can use LLMs. You should be upfront with it. We have at the end, we have a table where we ask them which kind of question do you use, where do you use LLMs, and they are, they should commit and say what they do, and they do what they say. But how confident are we that this approach provides useful human capital for future careers? I'm not sure. This would be like an open question.
Annika is asking an interesting question. If you're losing the measurement of learning, in other words, if the measurement of skills is now mismeasured because of the AI, AI brings essentially a measurement error in the skills.
Yeah.
So because it compresses the distribution and it compresses it more at the bottom towards the average.
Yeah.
So how are you thinking about assessment reforms to match the true distribution of skills?
At the moment, we have two projects in there, and these projects also count for the final grade. They count for 70% or 60%. For we have one, yeah, 70% of the final grade, and only 30% counts the exam at the end of the course. What we do is we do these two projects, and they count only 50%, and the exam counts also for 50%. What we also do is we have some questions in there that is difficult for an AI, or where we can like easily detect what AI misses. So they often miss some nuance for these different questions. But you're right. It's definitely a problem to have a machine that can answer questions this skillfully. Okay, I think
There's one more question that I want to highlight. It comes from Cloda. Do you think so? What are the long-term implications of learning from the AI use? And yeah, go on.
it's we have to
And
think about, yeah. Do you hear me? Okay.
yeah,
We have to think about how to implement AI, like in a way that fits the need of the students, like doing with an AI tutor, for example. That would be a good fit. But we also have to teach them how to use AI responsibly. But yeah, my take from this experiment is that we have a de-skilling of strong students, and the incentive for strong students is to use LLMs because they can like shortcut their answers and have answers that are, yeah, they are not incentivized to go the extra mile, to think one step ahead and to do like the 10% that is missing at the end. So that's really a big problem. Yeah.
final question that comes from Doug. It seems that like the skills used to complete the project are quite different from the skills measured on the exam. So we may
No,
think
no,
that
no, 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 no.
bringing, yeah, go
It's the
on.
exact same skills because the questions are based on the questions question in the exam are based on the questions done in the project. So they are one to one. If you've done this, what you've done in the project, you've done you can answer the question in the final exam. If you did not do the project, you could not answer, or it's really hard to answer the question in the final exam. So they are really linked. It's not they are different.
Can I just jump in on that one?
Yeah.
I mean,
Of
I guess
course.
what I meant is that in the project, they're actually constructing all this stuff. And so they're either learning or not learning, but they're using the tools, and the tools might include AI, to generate lots of tables and things. But then on the exam, they're being asked to interpret tables. And I think of generating tables as quite different from interpreting what the tables mean. That's what I was getting at.
In the project, they are also interpreting the tables. They're not producing it, just that they are there. They have to describe the table, they have to interpret the table, and also the graphics they produce. And we have questions about coding in the exam, but the questions the for the projects are here. You have a table. What is it saying? What's the interpretation? You're correct, but I would strongly argue against that. These are two different skills because they have to do it in the in the project as well.
So were
Excellent.
you as worried about this as I am? Like these results, they're pretty. I mean, I'm not saying what you did is bad at all. I'm just saying these like the students are not learning. It
Yeah,
sure seems like. I mean,
this
using the
is
term de-skilling.
yeah. I used it, I think, in the presentation as well. Yeah, that's pretty scary. And it's also when you think about PhDs at the end. we don't have had a graduate not coding anything in the past. At least I didn't. So I could always get back to the coding skills of my students in the PhD level. But now my results indicate that even the strong ones didn't code anymore, and that's scary. Yeah.
Okay, I will encourage further discussion on these issues of learning and mismeasurement of skills for the social after, or maybe private email exchange after. But now we need to move on with the second presentation. Thank you, Alex, and thank you all for asking these interesting questions. Please keep them coming for the second presentation.